Hello and welcome to Steps to Maths, and today we're going to be doing a bit of a revision of functions. So a little reminder, a function is a machine that takes some input and gives you some output. So for any given input, we get a certain output. Just another way of writing this. Instead of saying input goes into a function, this is how we write it. We write f bracket input, and that input is taken to an output. What you more likely see it is f of x. X is just some input. Takes us to 3x minus 5, for example. So this little example here, 3x minus 5, this just tells you what the function does. It takes this input x, multiplies it by 3, and then subtracts 5. When it's multiplied by 3 and subtracted by 5, and 5 is subtracted from it, that is the output. So we have an input value, x, and an output value, 3x minus 5. So for every input that x, we have an output 3x minus 5. So this just tells you what the function does, and it tells you the relationship between the input and the output. When we want to graph a function, what we usually want to do is we want to graph it on an xy plane like this. We have an input in this direction and an output here. Okay, so this just means every point on this plane, any particular point here. So for an input of 7, we get an output of 3. So every point on the plane, remember, is a couple in a relationship, and this is the input and this is the output. When we want to graph a function, we pick a certain number of inputs. So usually we write a table. We have an x and an f of x. X is our inputs, f of x is our outputs, and we want to find out for each input that we have what the output is. Now usually for the questions for the moment you'll be told what values to pick as inputs, but the best ones generally to pick are going to be 0 for starters and 1. Then we can pick 2, 3, 4. So these are just example values to pick, and we'll have a look and see what kind of output we get from that. So let's have an example. F of x is equal to 3x take away 5. That means you take your input, you multiply it by 3, and then you subtract 5. So let's do that with 0. 3 times 0 take away 5, and that of course is negative 5. Our couple then is 0, negative 5. That's our first point on our graph. You've done this already, this is just a little bit of revision. 1 is going to be 3 times 1 take away 5 is equal to minus 2. Our couple is 1, minus 2. These are just example couples, remember. This function is true for every possible value of x, an infinite set of numbers. So we just want a couple of examples so that we can draw a picture. If you're not quite sure what the answer is, just put this into your calculator. 3 times 3 take away 5 is equal to 9 take away 5 equals 4. Our couple is 3, 4. Next one. 4, 3 times 4 take away 5 is equal to 12 take away 5 equals 7. Our couple is 4, 7. You'll notice also this goes up in ones. 0, 1, 2, 3, 4. This goes up in threes from negative 5 to negative 2 to 1, 4, 7. So remember we talked about the slope. The slope tells you that every time this goes up by 1, then this will increase by the slope, and the slope is 3. And last week you figured out that the slope is this value here. Let's have a look at graphing some of these values. So we had 0, negative 5. So 0, minus 1, 2. That's 0, negative 5. 1, negative 2. 2, 1. 3, 4. And 4, 7. Again, you'll notice every time you go across 1, you go up 3. So we know that the slope is 3. Now, usually when we're drawing a graph, I would number these. So don't forget to number these. I'm just not doing that because this is just an example. Okay, so there we go. There we have a function. Remember, a function is a relationship between an input and an output. When we draw a graph, we show a relationship as a couple, every input associated with every output. So there's an infinite set of inputs here, and every one of those makes a point, and we've got all these points here that makes a straight line. Remember again, when a function looks like 3x minus 5, we get a straight line. When a function has an x squared in it, then we don't get a straight line. So our graph of our function will tell us something about what we're doing. Okay, so that was just a little bit of revision about graphing things, and now we're going to have a look at finding the slope of a line given any 2 points in it. Okay, so let's pick a point here and a point here. This point here is minus 2 comma minus -2 comma minus 11. This point here we already know is going to be 4 comma and 4 comma 7. So these are 2 points that we just happen to have on this line. And using these 2 points, I want to find out what the slope of this line. Remember what the slope is. The slope is every time we increase by 1, how much we go up in this direction. So from any point, when I increase this by 1, how much do I increase this by? So that's the question. So let's have a look. Given 2 points, if we didn't have the graph, we just had the 2 points, I would know how much have I increased from here to here, from -2 to 4. Well, let's label this time, okay? So this is couple 2, and this is couple 1. It doesn't matter which one's which, as we'll see in a minute. So this is couple 2, and this is couple 1. Because this is couple 2, I'm going to say x2, y2. That just means the input value for couple 2, the little subscript there means couple 2, the y value for couple 2. And of course, for couple 1, this is going to be the x value and the y value for couple 1, the x value for couple 1, the y value for couple 1. So that's just how we label these things, and it's going to be useful to know how to label things in the future. So how much have we gone across from here to here? Let's have a look. Well, it's going to be x2 minus x1. Okay, the distance from here to here, how much have we gone across? We've gone across this much. Let's have a look at that up here. How much have we gone across? We've gone across from -2 to +4, and we want to know how far that is. To measure distance, we take the bigger number and subtract the smaller number. So that's 4 take away -2 is equal to 6. So we can see that distance there is 6. 1, 2, 3, 4, 5, 6. To measure distance, you subtract. So the x value of couple 2 take away the x value of couple 1 is 4, take away -2 is 6. That gives us how far in the x direction we have gone. Okay. This is straightforward enough. It might seem a little bit complicated because we're introducing using labels. What do you think y2 minus y1 tells us? Well, y2 is of course 7. y1 is -11. And y2 minus y1, so it's the y value of couple 2 minus the y value of couple 1. And that tells us the distance from there to there. If you don't know what a minus minus is, a minus minus is a plus. When you subtract a minus number, you get a plus. That's just how we measure distance here. So we can see that that distance there is 11. So to go from couple 1 to couple 2, we've gone up 18 places. To go from couple 1 to couple 2, we've gone up 6 places. To find the slope, we need to know how much have we gone up for each one of these. Let's just write this down. So the slope is how much y, which is how much up or down, has increased for each step in the x direction. And the x direction, of course, is how much right we've gone. So for each step we take right, how much have we gone up or down? Well, x2 minus x1, so we've taken 6 steps and we've increased by 18. So to find out how much we've done for each step, we go 18 divided by 6. Easy? Okay, so what you will see, now remember, where did we get 18 from? 18 was how much we increased in y from couple 1 to couple 2. This is just how far it is from 1 to 2. That's how you find out how far it is from 1 to 2, you subtract. So we found out y increased by 18. We found that x increased by 6 steps. So for each step, we had 18 divided by 6. There will be a formula for this. y2 minus y1. How much you've increased in y divided by how many steps you took to make that increase. That's your slope. How much you've increased and how many steps to make that increase. We're dividing our increase by how many steps we took to find out our increase for each step. Increase per step is the slope. So remember, that's what the slope is, okay? The slope is every step we take, how much we increase in the y direction for each step we take in the x direction. So that's going to be how much the total amount we've increased in the y direction divided by how many steps we took will tell us what the increase per step is. An increase of 18 over 6 steps is an increase of 3 per step, and that is called the slope. So if you're given the equation, if you're given the function, we know we can read off the slope straight away here. But if you're given 2 points on a graph, couple 1 and couple 2, we use a formula. The formula is y2 minus y1 over x2 minus x1. That's in your tables. So I just wanted you to know what that meant. That means the distance from the y value of couple 1 to the y value of couple 2. So how much you've gone up from couple 1 to couple 2, and how far right you've gone from couple 1 to couple 2. How much up you've gone from couple 1 to couple 2, how far right you've gone from couple 1 to couple 2. Okay, so what you do is you write down the 2 couples, you label them. Let's have a look at labeling couples. Let's pick another 2 random couples. We don't know a function, we don't have a graph, we don't know anything, we just know we've got 2 points. We've got the point 3, 7. We have the point 18, -5. We want to know what the slope of a line between those 2 places is. We label couple 1 with x1, y1. We label couple 2 with x2, y2. Our slope of the line between those 2 points is how much y has changed over how much x has changed. Okay, so in this case, y2 is -5. Let's subtract y1. over x2 is 18. Let's subtract x1, which is 3. Just a little note. Usually in substitution, whenever I'm substituting, I like to put things in brackets. That helps make sure that I get the right answer. And you can just stick this into a calculator if you like, or you can work it out. If you work it out, that's going to be negative 12 over 15. And you can simplify that if you like and get a slightly more simple answer. So, what was that all about? That was a little reminder that a function takes an input to an output. It takes a set of inputs to a set of outputs. When we want to graph it, we write our inputs, we calculate our output, we find all the couples, and we can draw a graph. Here is a picture of our graph. We've picked 2 couples on this. All of the infinite points here are a couple. Let's just pick 2 of them. And we label them x1, y1 for couple 1, x2, y2 for couple 2. Using that information, we can find our slope. If you like, you just use the formula. So this was just a little explanation of what the formula is. It's the change in y over the change in x. This is a symbol you probably won't come across in school too much, but it just means the change in y over the change in x. In this particular case, it's the increase divided by the number of steps is equal to the increase per step, or the increase for each step, and that's called the slope. Okay, so a little bit complicated, a little bit talky. So if you're interested in all the talky stuff, that's fine. If you're not interested in the talky stuff, that's fine too. You just take the 2 points, you label them, you put them into a formula. When you're substituting your values, 3, 7, 18, negative 5, put them in brackets into the formula. So when you had y2, we replaced it with minus 5 in brackets. When we had y1, we replaced it with 7 in brackets. The reason for that is just to make sure that we don't have problems with numbers like this. Just makes sure that you get the right answer when you put it in a calculator. Okay, so go ahead and do that and answer those questions on the slope of a line between 2 points.